Observability and SRE Part 9. This episode has 14 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Private Service Connect. How would you use Private Service Connect for private service access, and how would you debug connectivity failures? Here's a strong way to approach it. Use Private Service Connect to expose a service, yours or a managed GCP service, privately to consumer VPCs without VPC peering, publishing a service attachment on the producer side and creating an endpoint in the consumer VPC. Debug connectivity by checking the PSC endpoint status, accepted or pending or rejected, verifying firewall rules allow traffic to the PSC endpoint IP, confirming DNS resolves to the private endpoint rather than a public address, and checking the producer side service attachments connection acceptance list. Nice. Let's continue. Question 2. Terraform secrets. How would you prevent secrets from leaking into Terraform state, plans, logs, and CI or CD output? Here's a strong way to approach it. Avoid passing raw secret values as Terraform variables where possible. Instead, reference secrets already stored in Secret Manager and grant the resource access to fetch them at runtime rather than embedding the value in Terraform config. Mark sensitive variables and outputs with sensitive equals true so they're redacted from CLI output and plan summaries. Store state in an encrypted remote backend with restricted access. State still contains secret values in plain text. And ensure CI logs mask any secret adjacent output. Great. Moving on. Question 3. Terraform import. A team created resources manually and wants them managed by Terraform. How would you plan imports and reduce risk? Here's a strong way to approach it. Write the Terraform resource configuration to match the existing resource's actual settings first, then use Terraform import, or the newer the exact commands and code are in the written question bank. Alright, next question. Question 4. GitHub Actions Security. How would you secure GitHub Actions for cloud deployments using OIDC, environments, approvals, least privilege, and secret handling? Here's a strong way to approach it. Use OIDC Federation so GitHub Actions authenticates to GCP with short-lived tokens instead of long-lived service account keys stored as secrets. Scope the associated service account to only the permissions that workflow needs. And use GitHub environments with required reviewers for deployments to production. Pin action versions to a commit SHA, not a mutable tag, to prevent supply chain tampering. And ensure secrets are scoped to the specific environment rather than available to every workflow in the repo. Let's keep going. Question 5. Release rollback. A canary deployment passes technical metrics but business metrics drop. How would you decide rollback versus continue? Here's a strong way to approach it. Treat business metric regression as seriously as technical metric regression. A canary that's technically healthy but drives down conversion or revenue is still a failed release. Roll back immediately if the business impact is significant and ongoing, since the cost of staying live and investigating usually exceeds the cost of a quick rollback. Only continue investigating live if the metric drop is small, ambiguous, or plausibly caused by something unrelated to the release, seasonality, an unrelated incident that you can verify quickly. On to the next one. Question 6. Toil reduction. How would you identify operational toil in a platform team and turn it into automation backlog? Here's a strong way to approach it. Track recurring manual work explicitly, ticket categories, time spent per task type, and repeated Slack requests, to find the highest frequency, highest effort toil rather than guessing. Prioritize automation candidates by frequency x time saved versus build effort, and treat toil reduction as a real backlog item with the same rigor as feature work, since it competes for the same engineering time and needs to be justified with expected ROI. Good. Here's another one. Question 7. Chaos testing. How would you introduce chaos engineering safely for GKE workloads and what failure modes would you test first? Here's a strong way to approach it. Start in staging with well-understood, low blast radius experiments, killing a single pod, simulating a node drain, before ever running chaos experiments in production, and always have a clear abort mechanism. Test the failure modes most likely to actually occur first. pod crashes, node failures, and dependency timeouts, since these validate whether your health checks, PDBs, and retry logic actually work as designed rather than just looking correct on paper. Nice. Let's continue. Question 8. Logging cost. Cloud logging cost is growing quickly. How would you reduce cost while preserving incident debugging value? Here's a strong way to approach it. Use log exclusion filters to drop high volume, low value logs, health check noise, verbose debug logs in production before they're ingested and built, and root logs you still want to keep long-term to cheaper storage. A cloud storage sink, rather than paying cloud logging's retention rate for everything. Keep sufficient structured context in the logs you do keep, request IDs, error details, so reducing volume doesn't reduce the ability to actually debug an incident when it matters. Great. Moving on. Question 9. Alert ownership. How would you ensure every alert has an owner, runbook, slow relationship, and actionable threshold? Here's a strong way to approach it. Require every new alert to be tied to a specific team or on-call rotation, linked to a runbook describing the response steps, not just the symptom, and justify its threshold against an slow or known user impact signal rather than an arbitrary number. Periodically audit alerts that fire frequently without action taken or that page the wrong team, and remove or fix alerts that don't meet this bar, since unknown or non-actionable alerts are what causes alert fatigue. Alright, next question. Question 10. SCC operations. How would you operationalize Security Command Center findings into ticketing, prioritization, remediation, and reporting? Here's a strong way to approach it. Pipe SCC findings into your ticketing system automatically with severity-based routing and SLAs. Prioritize based on both severity and exploitability or exposure. An internet-facing critical finding outranks an internal medium one. And track remediation to actual verified closure, not just ticket status. Provide a rolling report to leadership on open findings by age and severity so unresolved risk stays visible rather than accumulating silently. Let's keep going. Question 11. SLSA or provenance. How would you explain SLSA, provenance, and signed artifacts to a team building a secure delivery platform? Here's a strong way to approach it. Explain SLSA as a framework that gives you graduated confidence that an artifact was built the way you think it was, from basic build tracking to fully verified, tamper-resistant build provenance. And provenance is the metadata proving where and how an artifact was built, source commit, build system, inputs, signed artifacts, via cosign or sigstore. Let a deployment target cryptographically verify an image wasn't tampered with after the CI pipeline built it, which is what binary authorization enforces before allowing deployment. On to the next one. Question 12. Golden path adoption. Teams avoid your golden path and create their own pipelines. How would you understand why and improve adoption? Here's a strong way to approach it. Talk directly to the teams bypassing it rather than assuming. The golden path is usually avoided because it's missing a capability they need, too rigid for their use case, or has a worse developer experience than rolling their own. Fix the actual gap. Involve early adopters in shaping the next iteration so it reflects real needs, and measure adoption as a product metric you actively improve rather than mandating compliance, which tends to produce quiet workarounds instead of genuine adoption. Good. Here's another one. Question 13. Service catalog. How would you design service ownership metadata, dependency mapping, and production readiness status in a service catalog? Here's a strong way to approach it. Require every service to register ownership, team, on-call, Slack channel, a dependency list, what it calls and what calls it ideally derived automatically from tracing data rather than hand-maintained, and a production readiness status, checklist of reliability or security gates passed. Make the catalog the source of truth other tooling reads from, alerting routes, on-call paging, cost attribution so it stays accurate through use rather than becoming stale documentation nobody updates. Nice. Let's continue. Question 14. Batch inference. How would you design batch inference on GCP using GKE, Cloud Run Jobs, Vertex AI, or Composer, and what trade-offs matter? Here's a strong way to approach it. Use Cloud Run jobs or GKE jobs or cron jobs for straightforward scheduled batch scoring with moderate scale. Vertex AI batch prediction for a fully managed experience tightly integrated with the model registry. And Cloud Composer or Airflow when the batch job is one step in a larger multi-stage pipeline with dependencies. The trade-off is operational simplicity versus control. Managed Vertex AI batch prediction requires the least maintenance but the least customization. GKE jobs give full control at the cost of managing scaling and retries yourself. Great. Moving on. That wraps up this episode. Nice work practicing, and see you in the next one.